the pioneerism methods. Okay, so today we continue. Let's say we were live. Let's say for 10 minutes ago, and we worked out. Let's say the exact roots of the 10-degree polynomial equation, where all the roots are complex. Okay, I will deal with the same example, but the last coefficient will be changed. Okay, and then we will get two real numbers and the other are complex. Okay, so let's work. Let's start. I will share first the screen. Okay, this is me, Mourad Sultan Ezouidi, finals and methods. Uh, I will apply my theorem for solving 2 to the power 10. Okay, and we focus on the two real numbers and the 8 complex numbers. Okay, I was, let's say, live 10 minutes ago. Now we are going to continue solving the exponent to the power. Okay, this amount of kids. I will share first this one. I want to share this first. Share this. Share. Okay. Okay, I will share this first. Okay. This, this is my channel. Okay, 1 minute. Just 1 minute, my professors and colleagues, learners and students. Just 1 moment. I will start solving this polynomial to the power 10. Okay. Okay, x. Done. Okay. Now make it. Okay, close this one. So here, yes, here where I can share the screen on tiles. Okay, okay, audience, okay, share. So it's me, Mourad Sultan Ezouidi. Hello again. How are you doing? I wish that everyone is okay. And today we thought that I will just focus on the same example that I already explained it for 10 minutes ago, and we are going to change the last coefficient. Okay, and we'll see that we will get two real numbers and 8 complex numbers for this 10th degree polynomial equation. Okay, so let's start this one, my kids. Okay, here this is the polynomial to the power 10. Okay, it comes here. This is regarding to the theorem of Mourad Sultan Ezouidi. Okay, I published more than 5 books in edition of Iraq, University of Iraq, and in Amazon also. And the books are ready for sold for sale. If you want to sell my books, okay, it's an occasion for you to get to know about how can you solve them to the power to the power to the power 10. Okay, so this is the problem to the power n learners. X raised to the power 10 minus 10x raised to the power 9 plus 45x raised to the power 8 minus 120x 7 plus 210x raised to the power 6 minus 251x raised to the power 5 plus 205x raised to the power 4 minus 110x cubed plus 35x squared minus 5x minus 1 equals 0. So this is in fact is going to the power n to the power 10. I'm going to find my new 10 degree polynomial equation, okay, where the coefficient has labeled as S subscript k minus 1, okay, or it's called the discriminant formula of Mr. Mourad Ezouidi from the sum from 0 to k, combination n minus r choose k minus r, and is to the power r between parentheses negative 0.2 k minus r times and k minus 1 equals 3. I apply this formula of me for k equals 0 up to 9, up to 10, sorry, okay, means k or r, yes, k ranges -1 up to 9. 10 minus 1 means 9. So S0 learns is 0. S1 is equal to 0. S2 here, this one S2. Of course, I use this formula, okay, the formula of mean, after making the expansion of this S subscript k minus 1 upon the k equals the 0 from k combination n minus r choose k minus r and raised to the power the comparative 0 by 0 for the q raised to the power k minus r times lr minus 1 k. So I will use this one and then make substitution. This is equal to 0. Explained this example before, but now the coefficient is are different. The last coefficient is minus 1. Therefore, S3 learners is equal to 0. You can use the calculation, is going to be equal to 0. And I'm going to find S4 to find S4 go to change K with 5. Give the discrete formula of Mourad, Sultan, Ezouidi. Therefore, S4 is equal to this. If you calculate, let's say the value of S4, you will find that is negative, let's say negative 10 raised to the power 5. Now I want to find the KS5. I should put K equals 6 in the discrete formula of Mr. Mourad Sultan Ezouidi. Okay, and we will try to calculate S5. Okay, so just use the calculator and we will, let's say, reach this. Okay, means that the value of S5 is equal to 0. But S4 we told is different to 0, which is equal to negative 10 raised to the power 5. Now the same procedure, okay, I will put k equals 7 to find S6. We put, let's say, the coefficient, all the coefficient of my original differential equation in this discrete formula when k equals 7, okay, that has been derived from discrete formula of mean, okay, and we find that is equal to 0. Now for k equal 8, I should find S7. So S7, my kids here, it's clear that is equal to 0. Now the last step, no, not the last step, yes, 10 minus 1. The last step, I will find S8. Yes, it's not the last step because the highest power is 10 9. So for k equal 9, I should find S8. For k equal 10, I should find S9 and S6. So this is the formula to find the coefficient of the ninth, the 10th coefficient. Take this 10th coefficient of my new 10 degree polynomial. Therefore, my kids here, S8 is equal to this formula, okay, that is generalized for any degree polynomial equation, okay. So here, my kids, just make the substitution and you get that the value of S8 is equal to 0. Take your time and calculate this, okay. Now we continue. I want to find S9 and the last coefficient of my Newton integral equation. I will get S9. So we should put K to 10 as this from the Mourad Sultan is ready. Okay. And this formula also, you see this one, SH is really Mourad. Okay. This theorem has named as the name of my father and mother. S Sultan, H Hania, me is really Mourad. This is also, if you will use this theorem, also you get the value of, you find the exact roots, okay, and sk subscript k minus 1, and of course, sk for the IQ also can be given. Therefore, the value of S9 learners is negative 10 raised to the power 10. Therefore, all the quotas are equal to 0 except S minus 1 and S4 and S9. I will put this. So my new discriminant, my new degree from the equation has to be written as that. X raised to the power 10 minus S0 for the Q or R is the difference. X raised to the power 9 plus S1 for the R, X raised to the power 8 minus S2 for the R, X raised to the power 7 plus S3 of the R, X raised to the power 6 minus S4 of the R, X raised to the power 5 plus S5 of the R, X raised to the power 4 minus S6 of the R, X raised to the power 3 plus S7 of the R, X squared minus S8 of the R, X plus S9 of the R equal to. Therefore, we told I will focus only on S on this one. I will make okay on S4 and plus S9. Okay, I will focus on this. And also on x raised to the power 10. The rest are equal to 0. Okay, I will write this here. P of x equal x raised to the power 10 minus s1 for the r x raised to the power 5 plus s9 for the equal 0. I will, this is, you can see it's a quadratic equation when putting y equal x raised to the power 5. So this one can be written as x5 squared minus s4 for the x5 raised to the power 1 plus s9 for the equal 0. Let y equal x raised to the power 5 means y squared minus s4 y raised to the power 1 plus s9. This is quadratic equation. Apply the discount formula of Mr. Sultan Ezouidi, and your new second degree from the equation has to be written as x squared minus s0 for the q dash x raised to the power 1 plus s1 for the q dash. So therefore, I'm going to solve this. For x, what is the value of x? Therefore, x squared equal minus s1 for the cube. Therefore, x has to be equal to plus negative root of minus s1 cube. Okay, this I will just write this for you. Means my kids, because it's very important. Okay, that's how this is x squared equal. I just write x equal plus negative root. Okay, root of what, my kids? Root of of minus 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 s1 for the q dash. Okay. Now s1 for the q dash equal in fact negative s4 for the r squared plus 4 times s9 for the r. Okay. The opposite of the quadratic equation that you already know. Okay. But the exact foundation or the exact uh, prediction to write it is like that. S1 of order 2 dash equal negative S4 of order R squared plus 4 times S9 for the R equal. I will use the coefficient. I will use S9 and S4. It will be negative because this is negative. S4 squared is negative 10 squared because this is negative 10 raised to the power 5. The squared plus 4 times negative 10 raised to the power 5. This one is equal to negative 5 10 raised to the power 5. You see, this is S1 of all the Q dash. Okay, we told like that. The x squared, this is 0, no need, plus S1 of all the Q. S1 is negative. I can put here is negative. When you transfer that, it will be positive. Therefore, I will proceed. I will tell that negative S1 of all the Q dash equals 5 times 10 raised to the power 5. Okay, then, okay, 5. Yes, 5 raised to the power 10. Therefore, y is what? It's y, this one, this one. The second origin, the original second degree polynomial equation. We receive the new second degree polynomial equation that is obtained from that. So y, which is x squared, equal, which is x raised to the power 5, or equal S4, because this is minus S4, minus 4, plus negative root of this, because this is x squared. This is plus 1, plus S1 according to dash, when it will be constant, it will be negative. Then when it will be negative, I should find the root of it. And then plus negative root of minus 1 according to dash. The S4 is negative 10 raised to the power 5 plus negative 5 times this. 10 raised to the power 5 raised to the power half will be 10 raised multiplied by 10 raised to the power 5 multiplied by root of 5. Of course, exponential 2k alpha. Okay? Because always this one is 1. Divide by 2. Now, I will write this as that. Okay. Uh-huh. Okay. So this one has to be divided by 2. Divided by 2. Good. Then this is y equal. Now x5 is equal to 10. This is, of course, this mark is divided by 2. Okay. according to the formula. Now I will make this, cut this, make 1 divided by 2, then comes up and change this by, okay, by minus 1 plus. Copy. This one, of course, can be like that, my kids. Okay. Now these are the fifth roots. Okay, these are the fifth roots. It remains the other fifth roots. So the other fifth roots, it will be plus negative, yes. So I should, yes, minus 1 I will write as exponential I pi. Raised to the power half, it will be exponential 2I pi divided by 5. Then multiply by exponential 2ki pi divided by 5. So minus 1 plus root of 5 exponential 1 over 5. Of course, this is divided by 2, Mr. Mourad. It is possible. This is plus. This is minus. I will make divide all by 2. Because in the formula is divided by 2. Okay. So these are the roots, my kids. I will take this one. I will take the first. It is possible. Okay. So this one. Yes, okay. I will write it here. Divide by 2. Of course, this one should be written as. So these are the 5 exact roots. It will be 10 plus 10 times this. This is x roots. Divide by 10. 10 divided by 10 is 1. 10 divided by 10 is 1. So plus only this. For the second one, of course, this one is divided and change the sign. It will be positive. This is okay the same, and this one will be positive. Okay, so these the kids are the roots of my fifth degree polynomial, and they are written in cells and in terms of exponential. So now I will give the example. Okay, let's come here first. I finished this one, my kids. So okay, now I will go to ChatGPT. Math solver. I will make this is minus 1 minus 1 equals 0. Solve this. So we have only method, but we have how many read roots? 2 read roots. And the other are 8 couplets. Okay. But he can't solve, you see? He can't solve this question. He uses graphical complex. In progress. Complex number. So he can do okay. Delete one. Yes. Okay. We can here. Solve again. Okay. Now my kids, for that, our term is here. So these are the roots, isn't it? This is equal. Yes. This is equal. So kids, 1k equal minus 1k equal 2, I will get the first three roots. 1k equal 0, I will get the second one. So we have only two roots. The other are complex. Okay? So I will give this equation to what? To ChatGPT. And he will not be able to answer me. Okay, ChatGPT. I told him, take your time, this one. Hey, find those. Hey, I finished it. I finished it. Okay. Now it's your role to give me the exact roots. Use Python if you need. Use Python if you want. If you want. But sure you can do it. Sure that it can do it. And do it. Okay. Do your best. Ooh, thank you. Okay. Okay. Man. Okay. Right. Okay. Nothing. Goodbye. This is my community report and hero. Okay. After that. Okay. This will give you the exact figures. Yes. Then write the exact roots. I understand. Okay. 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 Alpha. Okay. Now, all Wolfram Alpha can do. Wolfram and is enable. Is enable. I will give you this. I will give you the graphics. Thank you for replying. Please go ahead and provide the graphics when you are in class. It will be okay with it. Thank you. Okay. 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 The expression provide some but are very elegant in the presentation of units. To do what presentation needs. Okay, let's do it. You have provided the exact question for the real competencies. Okay. Then, okay. So thank you, my kids. This is really the pioneers and methods. Okay. So this one is maybe. These I will give in first. Okay, where is it? My kids, my professors, and colleagues, if you would like to understand more polynomial equation, you should practice the theorem. Even my books are in Amazon and edition of universities in Iraq. You can buy it. It's not expensive. Okay, so I will now give this to Mathways. Okay, wow. So he can do that. Find it. Thank you and goodbye. Goodbye. Only the Thank you and goodbye.